This is the last video of a 4-part series on arithmetic sequences for Algebra 1. Let's do some review before we get to new content. First of all, what does f of 3 mean in a sequence? F of 3 represents the third term of the sequence. Remember that the number on the inside tells us what term we're looking for. So if I put f of 1, I'm looking for the first term. F of 5, I'm looking for the fifth term, and so on and so forth. What does D mean? D represents the common difference. It's the number that we add or subtract between each term. So if I'm adding 5 between each term, that's my common difference. What is the formula to find the explicit formula of a sequence? Well, the formula we've been using is f of n equals d times n minus 1 plus f of 1. And as a refresher, remember d here is your common difference, and f of 1 is your first term. And lastly, what is the domain for a sequence and why? And remember, domain represents the input. So what numbers are we plugging into our formula? Well, the numbers we're plugging in are natural numbers. Those are the positive counting numbers. And the reason why we do that is we can't have a term 1.5. It just sounds weird. So I can't have picture 1.5, something like that. It's just odd. So the way I always remember it is you can't finish a race and place 1.5. So all of these things we're going to need for a new type of problem. So here I have a formula, or have a sequence, and I want to write the explicit formula for the arithmetic sequence. Now, just by looking at it, we couldn't tell it's arithmetic because we have some spaces, we have some things missing. So the problem has to tell us that. So we have to figure out how to write this formula, meaning we need to figure out the common difference and the first term. Now, in this case, the first term is obvious, it's 12, but finding the common difference is a little bit trickier here. But luckily, we have a formula. So here's the formula we're going to be using, and we can use this to find the common difference for any arithmetic sequence. This works for any of them. So let me review what this looks like. So we have f of b minus f of a over b minus a. So here's what this is referring to. So f of b is term b, f of a is term a, and then these are just the numbers, b minus a. Now this looks really complicated, and maybe my explanation wasn't the best, but let me show you what I mean going back to that problem. So what I'm going to do here is I'm going to start by numbering. So I know this is term 1, I have term 2, I have term 3, 4, and 5. So it looks like I'm missing terms 2 and 4. So I have 1, 3, and 5. So remember, to find our formula, we need f of 1, which in this case is 12, and we need our common difference. So it looks like that's what we need to find, the common difference. So d equals, I'm going to write the formula, f of b minus f of a over b minus a. So what I'm going to do is I'm going to use the terms I have. And so just to make it easy, I'm going to choose term 1, and I'm going to choose term 3. So here's how the formula works. So we're going to do f of 3 minus f of 1 over 3 minus 1. Now I want to point something out here. You notice how the 3's are kind of stacked over each other and the 1's are stacked over each other. If they do not line up vertically, you're doing something wrong here. So you see I have f of 3 minus f of 1 over 3 minus 1. Now this is where that review comes in handy. So what does f of 3 represent? Well, f of 3 represents the third term of the sequence, which in this case is negative 2. So it's going to be negative 2 minus f of 1. Well, f of 1, the first term of the sequence, 12, over 3 minus 1. And then from here, we're just going to work this out. So let's see, we have, that would be negative 14 over 2 equals negative 7. So there's my common difference, negative 7. So I'm subtracting 7 between each term. And we probably could have figured out the subtracting part based on the fact that my terms are getting smaller. Notice I go from 12 to negative 2 to negative 16. So let's fill in my terms to see if this works. So if I subtract subtract 7 here, I would get 5. Subtract 7, yes, that gets me to -2. Subtract 7, that gets me -9. Subtract 7, that gives me -16. So there's my common difference. Now we need to use this to find the formula. So we found our common difference, we found the first term. So let me change colors here. Let's plug in our formula. So f of n equals d times n minus 1 plus f of 1. So this is just like video 2. So f of n equals -7 times n minus 1 plus 12. And let's see what we get. So f of n equals -7n plus 7, I distributed, plus 12. So my formula here is f of n equals -7n plus 19. In the last video, we talked about this quote-unquote term 0. It technically doesn't exist, but it worked on our graph. So if I were to go backwards one term, I have a quote-unquote term 0. Technically doesn't exist, but stick with me here. Go backwards. So what minus 7 gives us 12? It's 19. And hey, that still works. It fits in my formula. Let's do another problem. So this one, we have the same idea. So I've got some terms missing, and I want to write the explicit formula. So let's start by numbering. So I have term 1, term 2, 3, 4. Now, unfortunately here, I'm missing term 1, so I'm going to have to do a little math to figure out what it is. So I'm going to use the formula f of b minus f of a over b minus a, and this finds our common difference. So it looks like the only terms I have are 2 and 4. So I have f of 4 minus f of 2. And notice I'm putting the bigger one first. So 4, so I'm looking at my term number, term 4, term 2, over 4 minus 2. Now it really doesn't matter. You could have f of 2 first. It'll still work out the same, so it doesn't matter. So, but make sure that they're stacked. So you see I have 4s on top of each other, 2s on top of each other. Now let's plug it in. So f of 4, my fourth term, -7, minus my second term, 15, over 4 minus 2. I'm going to go ahead and do that subtraction, which is 2. Okay, let's go ahead and simplify. So I have negative, 22 over 2. So my common difference is -11. All right, so let's think about this and make sure it works. So if I were to subtract 11, what would I get? I would get 4. And if I were to subtract 11, does it give me -7? It does, great. Now I need to backtrack a little bit. Let's backtrack, because I have to have term 1. So if I subtract 11, what minus 11 is 15? That's 26. So I now know my first term is 26. I know my common difference is -11. And I'm all set to use my formula. So let's do that. So f of n equals -11. Well, let's write it out again just to make sure we know it. F of n equals d times n minus 1 plus f of 1. Let's write it out just to get practice. So -11 times n minus 1 plus my first term, 26. So I get f of n equals -11n plus 11 plus 26, and combine those, get -11n plus 37. And there's my explicit formula. Now you can plug in numbers, make sure it works. You can do that, but let's look at my quote-unquote term 0 again. Quote-unquote. So if I were to backtrack to this elusive term 0, again, technically it doesn't exist in sequences, but subtracting 11, what minus 11 is 26? It's 37, which is the same in my formula. Let's do one last type of problem. So write the explicit formula f of n for the arithmetic sequence given that f of 1 equals 10 and f of 3 equals 2. So this wording is a little bit different, but it's the same type of problem. And one thing I recommend when you see these types of problems is write it out like you just saw. A lot of people have a hard time visualizing this type of problem without writing it out. So term 1, 2, 3, and 4. So according to the problem, f of 1, my first term here is 10. So I'm going to plug in 10. F of 3, my third term is 2. So what this tells me is my first term is 10, my second term is 2, or second term, my third term is 2. And so I'm going to find the formula. Now, I've already got my first term, so I don't need to go looking for that. But I do need to go looking for my common difference. So I'm going to use the formula. I'll write it over here. F of B minus F of A over B minus A. So let's plug it in. So I'm going to do F of 3 minus F of 1 over 3 minus 1. So my third term, 2, minus my first term, 10, over 2. Now this, because I'm running out of room, I'll go ahead and simplify it. Comes out to be negative 4. So that's negative 8 on top, divide by 2, get negative 4. So there's my common difference. There's my first term, and I'm off to the races. So I finished the problem like we've been doing. Let's write our formula. F of n equals d times n minus 1 plus f of 1. Again, keep writing it down. Practice makes permanent. So we have f of n equals negative 4 times n minus 1 plus my first term, 10. So let's distribute. So negative 4n plus 4 plus 10. I distributed my negative 4 here. And I get f of n equals negative 4n plus 14. Now notice there's my common difference, negative 4. And my quote-unquote term 0 would be 14 because I would be subtracting 4, which it's right here. And that's it. That concludes our 4-part series on arithmetic sequences for Algebra 1. Best of luck!